Assalamu alaikum wa rahmatullahi wa barakatuhu. And very good morning to all of my dear students. Welcome to the class. Today's topic is linear expansion. Linear expansion of solid. Okay. Now here in the previous video we have discussed the linear expansion, and today we will do some formula related to the linear expansion. In previous video we have already discussed the what is linear expansion, factors on the linear expansion. Okay. uh, in this video we will discuss this formula. Okay, before going to this formula, just let us read this one. What is it is written for recapitulations. Okay, look at this. When a solid in form of a rod, this is a rod, okay, and solid in a form of rod is heated, and you heat it, then the rod little bit expand, length of the rod will be expand more. Okay, so the expansion in the length is here, this is the length. After heating, length will be little bit more. So the length, for example, length is 10 centimeter, and after heating it will be 11 centimeter or 10 point something, 11 centimeter. So that 1 centimeter increase in the length, okay, 10 plus 1, that is the linear expansion. Okay, so the increase in the length of the metal rod on heating is called the linear expansion. Clear? Linear expansion depends on the original length, increase in temperature and material of the rod. Okay, more the length, more will be the expansion. Okay, if you applied more temperature, okay, more temperature, increase more temperature, the expansion will be more. And it is also depends on the material, that is different material, expansion will be the different. So this is discussed in the previous class. Please go and watch my previous class. Okay, now in today's class we will discuss this formula, coefficient of the linear expansion. Now look at this. Here look at this. LT L0 alpha T. Here L0 is the length of the rod at 0 degree centigrade, and its length is T degree centigrade is LT. Increase the length is given. Now look at this. What is given? For example, this is a rod. Okay, this is a rod. Okay, the temperature of the rod is 0 degree centigrade. Okay, right now. Okay, now the length of the rod at 0 degree centigrade is L0. L0. Clear? This is the initial, but after expansion the rod will be little bit more. Say if you increase the temperature from 0 to T degree centigrade, maybe the T degree is 0 to T equal to 1 2 3 4 5, anything. Okay, the temperature increases from 0 to T degree, then the length of the rod is also increases. How much? LT. Clear? At 0 degree centigrade the length of the rod is L0. At T degree centigrade the length of the rod is LT. If for example, if L0 equal to 15 centimeter, okay, at 0 degree centigrade, then at T degree centigrade the temperature is increases. If temperature increases, for example 10 degree, 100 degree, 1000 degree, then this 15 centimeter will increase, say 20 centimeters. So how much increase? 20 minus 15, that is 20 minus 15. And what is 20? LT minus L0. So that is the increase in length, LT minus L0. Is it clear? LT minus L0, that is increase in length when the temperature increases from 0 degree to T degree centigrade. Okay, now this is the increase in length is equal to L0 original length. That was the L0 original length. L0 is the original length. And one constant term, that is alpha. Alpha and T. That is, increase in length is equal to the original length L0, product of original length, and alpha and temperature, how much the temperature it is. Okay, now you are feeling facing difficulties. Now just take the value lt 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 equal to lt equal to 15 degree 20 degree centimeter 20 centimeter 20 centimeter. Wait, here lt equal to 20 centimeter at T degree centigrade. That is, T degree centigrade is 1000 degree centigrade. Rod is 1000 degree centigrade. At 1000 degree centigrade, its temperature is 20 centimeter. But what is the initial temperature? This is the length, increased length. But what is the initial temperature at 0 degree centigrade? At 0 degree centigrade, okay, L0 will be L0 was 15 centimeter. Okay, this was the original length, and this is the increased length. How much it is increased? LT minus L0, that is 20 minus 15, that is LT minus L0. This is the increased length. Okay, LT minus L0. Okay, this is the increased length. Now what is this one? L0 means that 15 centimeter. So we will write that LT minus L0 equal to L0. What is the value of L0? 15 centimeter, and one constant term alpha, and this T is this 100 degree centigrade into 100 degree centigrade. Okay, and we know LT minus L0 equal to, this value is equal to 20 minus 15, that is 5. So here we get 5 equal to 15 centimeter into alpha, and equal to 1000 degree centigrade. So this alpha is known as, this constant is known as, this alpha is known as the coefficient of linear expansion. Coefficient of linear expansion. Okay, coefficient of linear expansion. You will discuss, you will learn this coefficient of linear expansion in the higher class in detail, but here you just remember the equation. Okay, this alpha is coefficient of linear expansion, which depends on the material of the rod. Material of the rod. Alpha is different for the different substance. Its unit is per degree centigrade. So coefficient of linear expansion, what is the unit of coefficient of linear expansion? Per degree centigrade. Per degree centigrade. Clear? And it depends on the material. Different material having different coefficient of linear expansion. Okay, now look at this. Here some values is given. Coefficient of linear expansion, very important. The value of coefficient of linear expansion is given in the following table. Look at this here. Aluminium coefficient of linear expansion is 24. What is the unit of coefficient of linear expansion? That is alpha per degree centigrade. Per degree centigrade. This is unit, very important unit. SI unit. Okay, now not SI unit, just unit, it's called general unit. Now brass is 19, copper is 17. Okay, this is the coefficient of linear expansion. Now ivory is the alloy which almost does not expand on heating. This is why pendulum of the clock is made up of ivory. Look at this. The coefficient of linear expansion of ivory is minimum, that is 0.9. Okay, less than 1. It is less than 1. So if the coefficient of linear expansion is less or minimum, then it will expand. It do not expand, or expand little bit. Okay, so here the value of the coefficient of linear expansion is more of aluminium, it means the aluminium will expand more. If the coefficient of here value of brass is 19, the it will expand less than aluminium. If I ask that aluminium and steel, okay, the coefficient of linear expansion is 24 and 13, okay, value of alpha is 24 and value of alpha is 13. Now the both steel and aluminium giving the same temperature 1000 degrees centigrade, 1000 degrees centigrade. Now by watching the value, by knowing the value of coefficient of linear expansion, we can easily say which one will expand more. Simple, those value, the coefficient, if alpha value is more, then it expand more with at the same temperature, okay, at the given temperature. So aluminium will expand more than steel. Why? At 100 or at 1000 degrees centigrade. Why? Because the coefficient of linear expansion of the aluminium is more, okay. And we will use Iver in pendulum, that pendulum, the watch pendulum, okay, in clock, this type of clock was there in earlier, and there is a one pendulum is there, and that pendulum is just oscillate. So this pendulum, the bob of the pendulum is made up of Iver. Iver is a type of a alloy, okay, is a type of a alloy whose coefficient of linear expansion is 0.9. That's why it will not expand on heating or not contract, okay, not expand on heating. And if why it is not expand, why it is made of iron, Iver, because if it is made up of aluminium, it will expand, and if and when it is expand, the oscillation will be defected, and the oscillation in summer it will expand more, then the oscillation will change, and the in summer and in winter the clock will not give exact time, okay. The in summer and in winter, in summer the aluminium bob will expand, and if it is expand, the time, the clock will not give a proper or exact time. That's why it is made up of iron, Iver, whose coefficient of linear expansion is very very less. Clear? Hope you have understood. So this is all about the linear expansion, and one more example is given here. Pyrex glass also expand negligible on heating, okay. So Iver and Pyrex glass is negligible linear expansion, that is coefficient of linear expansion, that is value of alpha is negligible. If it is negligible, then it will expand, it will do not expand, okay, it doesn't expand, or it will expand negligible, okay. Clear? So this is all about the coefficient of linear expansion or linear expansion of solid, okay. Thank you.